Okay, let's try to get through the sample 1 problems for this first exam. All right, it says, let x be a function where f of 1 equals 5, f prime of 1 equals -2, and f double prime of 1 equals 3. Use local linearization at x equals 1 to estimate this. So first, let's remember our local linearization. This is approximately equal to f of a plus f prime of a times x minus a. And we are going to say we're doing it at x equals 1. Really, that's a equals 1, okay? So our linearization is going to be f of 1, which is 5, plus f prime of 1, which is -2, and I can times x minus 1. All right, so let's simplify that. 5 minus 2x plus 2, that's 7 minus 2x. So this is our linearization equation at f equals 1. So they want us to estimate it at f of 0.9. So we're going to use 0.9. 7 minus 2 times 0.9, or 5.2. So this should be the, this should be the answer to A. Now it says, do you expect your estimate from A to be an overestimate or underestimate? Justify your answer. So what you do at that point is you look at the second derivative. The second derivative is positive, which means concave up. And when it's concave up, the tangent lines sit below. Since the tangent lines sit below in this linearization, the linearization is estimated off tangent lines, right? Tangent line, which is below the curve. So that means it's an underestimation. Okay? And then it says, suppose the tangent line approximation near x equals 8 is this, and it's 3.75. So we can actually figure out f of 8 and f prime of 8. So let's look at that. I'm going to kind of come over here. All right. So if we're doing it near f of 8, it's going to be, this is going to be f of 8, right, plus f prime of 8, x minus 8. Now there's two unknowns. These are our two unknowns. Two unknowns means we need two equations, right? A system of equations that we can solve. So the first one is near 8.05. That's f of 8 plus f prime of 8. And this would be 8.05 minus 8. And that equals 3.75. I'm just going to clean that up a little bit. And this is 0.05, right? So plus 0.05 f prime of 8 equals 3.75. There's one equation. Our second equation is the linearization at 8.1. That's f of 8 plus f prime of 8 times 8.1 minus 8, and that equals 3.6. So f of 8 plus 0.1 f prime of 8 equals 3.6. Gotta make myself a little room here, okay? Here's my second equation. Two equations, two unknowns. I'm going to take the first one, and I'm going to solve for f of 8. All right, so if I take this, f of 8 equals 3.75 minus 0.75 f prime of 8. So you see how I manipulated that? And now I'll substitute that in right here. 3.75 minus 0.05 f prime of 8 plus 0.1 f prime of 8 equals 3.6. I'm going to subtract this over. And I'm also going to combine minus 0.05 f prime of 8 plus 0.1. So it'll be 0.05 f prime of 8, and that equals negative 0.15. I'll divide both sides, right? And I'll double check with my calculator here that negative 0.15 divided by 0.05 is equal to negative 3. So that means f prime of 8 equals negative 3. Well, what we have to do now is go back into this original equation, the equation we solved for. I'm going to bring it up here. So f of 8 then is equal to 3.75 minus 0.05 f prime of 8, which is negative 3. Okay? And if I calculate that, I get f of 8 equals 3.9. So those are part C. Sorry, that's a little bit messy, but that's actually very doable. All right, so where do we want to go next? Oops, I want to go back one. Find the dimensions given the minimum surface area of a closed rectangular box with a square base, which means x and x, and a height of h that has a volume of this. Well, the volume of this box is x times h, right? And the surface area, the two faces are x squared. So I have 2 of those, and then I have 4 of the rectangular ones, which are x times h. That's our surface area. Now, before I do anything else, I want to get everything in terms of one of the variables. So I'm going to solve for h. H equals 8 over x squared. So I'm going to say 2x squared plus 4x 8 over x squared. Okay, I think I have to double check this. So I'm going to simplify, take an x out here. So this becomes 2x squared plus 32 over x, which is 2x squared plus 32x minus 1, right? Now, it tells you actually, well, maybe it doesn't. I need to minimize the surface area. So I'm going to take the derivative of the surface area equation right here, which is 4x minus 32. Let's see if this works. If I set that equal to 0, I get 4x equals 32, x equals 8. Oh, I don't know if that's right. Let's see. So that means this is 8. This would be 64. No, that can't be right with the volume. Okay, this one, Matt, I got to come back to because I really am not sure what to do there. I got to look at it and spend some time, okay? So let's look at number 3. It says, consider this function right here, where we're looking only at x is greater than 0 and a and b are positive constants. This function has exactly one critical point, so let's find it. So if f of x equals ax ln of x minus bx, f prime of x, this first part needs to be the product rule. Derivative of the first part is a times b, which is ln of x, plus the first part, ax, times the derivative of ln of x, which guess what, is 1 over x, which those will cancel out, and the derivative of that part is b. So this becomes a ln of x plus a minus b, which equals a ln of x plus 1 minus b. Now, if I want the critical point, I set this equal to 0, right?